My name is Vasishta Malisetty. I'm a first year computer engineering student at Northeastern University, and I'm presenting the midterm project for EECE 2160 Embedded Design with Professor Julius Marpaung. So, the software and hardware used for this project was Quartus Prime Light Edition software version 18.1, the DE1 SoC FPGA developmental board, and the 4x4 matrix membrane keypad. So, we integrated these three technologies to create this project. So the project is having buttons for the keypad as inputs, and whatever button you press, that number will be displayed on the 7-segment display of the DE1 SoC. So when a button is not pressed, the DE1 SoC 7-segment display should be blank. However, when a button is pressed, it should display the number that is associated with each button. Releasing all the buttons will cause the display to show nothing. We need to design and implement a circuit that debounces the keypad to avoid any flickering. The buttons asterisk and hashtag represent E and F respectively. And although ideally only one button is pressed, if two or more buttons are pressed, then the display only displays the first number pressed. So the 4x4 matrix keypad has 8 pins that are connected to the GPIO of the D1 SoC. So the pins, basically 8, 7, 6, and 5, are going to go for each row, and 4, 3, 2, 1 are going to be for each column. And that's how the matrix keypad works, as you can see in the left illustration. The core schematic designed for this project used 4 row inputs that were debounced. Those went into a bus line that goes into a compare block that checks if a button is pressed. Based on that logic, we'll go into a XOR gate, which will stop the scanner for the columns when a button is pressed. And then once it stops scanning, it will select an option for the correct column that is scanned, and then output the columns. The rows and columns are then reduced to 2-bit inputs for the 7-segment display, and then the number was displayed. There's also some secondary logic in the bottom left corner that will hold that value, which we'll see later on when for the problems that are encountered. So some issues that were encountered were having to do with when two buttons were pressed simultaneously. And 2 buttons were pressed simultaneously in the same column, the higher number would be displayed. But the project goals clearly state that the first number should be displayed. And this is a very long and tedious problem that wasn't solved until the very last day for the project. Another issue was that when you press 2 buttons in the same row, those buttons are actually disabled. The display doesn't display anything when it should display the first button pressed. And a third problem was the initial scanner used. I had initially used a 4-bit scanner that would cycle through every possible number between 0000 and 1111, but it proved to be very efficient in the previous iterations of the schematic. So the solutions for it were, for the 4-bit counter, we instead implemented a 2-bit counter that incremented through from 00 to 11, so only 4 possible options. And then that would select a option in the mux, the 4x1 mux, which is displayed in the top right corner. Also, for flickering on the 7-segment display, we used debouncers as depicted in the middle picture. And then for, again, the problem where the columns, the higher in value would be displayed, we had a hold feature using an up counter that only held the first button pressed and didn't store a new value until that button was let go of. And these are the schematics for those implementations. And then now is the demo for my project. My name is Vasishta Malisetty. This is my midterm project for EECE 2160 with Professor Dr. Julius Marpaung. This design has a 4x4 matrix keypad along with a DE1 SoC, and the way it works is that if I click a button on the 4x4 matrix keypad, it'll display on the 7-segment display found in the DE1 SoC. So if I click a 1, 2, 3, A, 4, 5, 6, B, 7, 8, 9, C, E, 0, F, and D. This is my logic for the design. So the way it works, it has 4 row inputs, and they're inverted, so that they start out as low, and then they go through debouncers with the inputs of the rows and a debounce thing from a clock that will be found later on in the design. And they go into 4-bit wide bus line, which goes into a compare block that checks if the row input value is greater than 0. So whenever a button is clicked, it will always be greater than 0. And then it'll be either 0, this line here will be 0 if a button is not clicked, or 1 if it is. This is an auxiliary node line called enable, which will be used to enable the 7-segment display, so that way it'll only turn on when a button is pressed. It goes to a XOR gate, which also has a VCC input. That way, if a button is pressed, it'll be 1 and 1, which will stop this scanner, and if a button isn't pressed, it will continue scanning. The scanner is a 2-bit scanner up counter, and it has the XOR gate as a clock enable and a clock as the clock. And it has this debounce auxiliary node line, which was found earlier in the design. So that way, it scans through 4 possible options, 0, 0, 0, 1, 1, 0, 1, 1. And when the scanner is stopped, it'll select the correct column for when I click a button. So it goes into this 4x1 mux. The mux has 4 options, and these values here, 7, 11, 13, 14, correspond with the binary values of the columns that we need to scan. So like for column 1, it would be 0, 1, 1, 1, 1. For column 2, it would be 1, 0, 1, 1. Column 3, 1, 1, 0, 1, and column 4, 1, 1, 1, 0. It'll select the correct value, and then it'll output a 4-bit wide output for the columns. It's separated in this logic here into its individual bits, and then both the row inputs and the column outputs are then reduced to 2-bit inputs for the 7-segment display as seen here. And here's the enable switch that we saw earlier in the design over here. And then based on min terms calculated through the truth table, it would display the correct value. There's also a hold feature, as I haven't shown yet, but if I click a button on the same, or not in the same row or column, only the first button is shown. If I click a button in the same column, only the first button is shown, as you can see here. But if I click a value that's in the same row, then it is disabled, as you can see here. So this was my solution for the column override. So basically it has the row inputs from before over here as its input, and then it has a grounded clock. And it also has a asynchronous load from a debouncer, where it uses the debounce from the clock and the enable switch from the button press checker as inputs. And then it outputs a row output that will be put into the 7-segment display. But the way it works is that only if once a button is clicked, it will not override that value until that button is let go of, which helps with the column override. So that way, only the first button is shown when you press a button. And yeah, that is my design.